My name is Seung-Yup Choi, and I'm a lead engineer and manager in streaming team at VDMS, and I'm in charge of developing streaming platform. In this presentation, I'm going to discuss streaming by NGINX. Everybody knows that NGINX is a very good web server, but not many people know that NGINX is also a very good streaming server. Let's look at how we are going to use NGINX as a streaming server. First, I'm going to review different methods of offering video from your website. And I'm going to present NGINX Rtmp module. And I'm going to review NGINX Plus that has streaming features. And the most important part of this presentation is going to be how to do HTTP VOD streaming on HLS and DASH using NGINX. Let's review different methods of offering video from your website. The most primitive way and the oldest way of offering video is progressive download. Clients have media player plugin in their browser, and that media player plugin requests the media file, and the player plays the video while the video is still being downloaded. There are two requirements for the video to be played smoothly. The download speed has to be higher than the play speed, and the metadata of the video has to be located at the beginning of the video. If the metadata is located at the end of the video, then the player cannot start the video until it receives the metadata part of the video. That is a very old way of offering video. Most browsers today is capable of HTML5. HTML5 allows the videos to be natively played by the browser. It supports video tag by HTML5 spec, but that is only a part of the aspects. The most important part is that the browser can now natively play the video file, mostly MP4 file. Unlike the old progressive download method, the browsers today are smart enough to make multiple HTTP byte range requests for the video file. So even if the metadata is located at the end of the video, the browsers can quickly start the video without any delay. Let me show you an example of native playback by a browser. So I just play an MP4 file using a browser. Then you can see that it is not just a single request. We get multiple requests with byte range. And the browser requests the metadata part of the video immediately, so that you can play the video without any delay. Rtmp is a proprietary protocol by Adobe, and it became the most popular streaming protocol in mid-2000. The reason was Adobe Flash Media Server was one of the best streaming solutions at the time. A good thing about Rtmp at that time was, Adobe Flash Player was installed almost everywhere, but not anymore. So at the time, Rtmp was able to be played in almost any clients. And another good advantage of Rtmp that is still valid today is that can allow very low latency. If you deliver Rtmp live stream, then the end-to-end latency could be just 2 to 3 seconds. That is almost impossible by different other streaming protocols. Disadvantages of Rtmp is that it requires Adobe Flash Player plugin, which nobody wants to install these days. And Rtmp cannot utilize the HTTP-based infrastructure for delivery, caching, and load balancing because it is a proprietary protocol. And Rtmp protocol was designed before the technology for dynamic bitrate switching was matured. So Rtmp is lacking the whole bitrate switching features. More and more streaming traffics are moving from proprietary protocols like Rtmp to HTTP-based protocols. The basic idea of HTTP-based protocols is the original video file, like MP4, is divided into smaller chunks. Each smaller chunk represents only a few seconds of video, and the server provides manifest file that is like a playlist that has all segment files, and the player requests the manifest, and when the player receives the manifest, it makes a sequence of requests for each individual segment file. So it plays the first segment, and at the same time, it downloads the second segment, and when the first segment is done, then it starts playing the second segment, and at the same time, it requests the third segment. This kind of technology was first introduced in 2007 by Move Networks, and after that, Microsoft developed Microsoft Smooth Streaming. Adobe developed HDS. Apple developed HLS. So it seems like everybody made a different implementation from the same idea. People didn't like that situation. So people came up with a standardized HTTP-based protocol called MPEG-DASH. Since then, Microsoft Smooth and Adobe HDS has been losing their foothold in the streaming industry, but Apple still keeps pushing their HLS protocol, and MPEG-DASH is getting more and more accepted. So HLS and DASH are the two thriving HTTP-based protocols today. Multi-screen delivery is something content providers are struggling with. So the purpose is we want to support as many clients as possible. Each different clients can only play certain type of video. Most browsers today that is capable of media source extension can play MPEG-DASH. Apple devices like iPhone, iPad can play HLS. Old browsers that has Adobe Flash plugin can play Rtmp. Some clients that can natively play MP4 file can just get an MP4 and play that. So in order to cover all those different type of clients, we want to provide all these different formats from the server. And MP4 is simple because it is just a file delivered over HTTP. In order to offer Rtmp, we need an Rtmp server, like Adobe Media Server or Wowza. In order to offer HLS and DASH, the file has to be processed for HLS or DASH files, and then the HLS and DASH files are delivered over HTTP. So we can consider HLS and DASH in the same category. They require an additional repackaging step, and then the files are delivered over HTTP. So let's consider HLS and we want to support Rtmp Live, Rtmp VOD, HTTP Live, including HLS Live and DASH Live, HTTP VOD, including HLS VOD and DASH VOD. There is an open source module called NGINX Rtmp module that can cover Rtmp Live, Rtmp VOD, HTTP Live, including HLS Live and DASH Live, but not HTTP VOD. NGINX Rtmp module can be downloaded from this Git location, and all information about NGINX Rtmp module can be found from the developer's blog. You should download the NGINX source and download the Rtmp module source, and then you compile the NGINX using Rtmp module as an edit module, and you install it. Then your NGINX is going to work as a streaming server. If you install NGINX Rtmp module, then you can offer Rtmp streaming. If you want to offer Rtmp VOD, you can define Rtmp block in the NGINX config file. That is a separate block outside HTTP block. And you define Rtmp, and you put server, and you define application, and you specify the location of the media file using play directive. You can also define a live application. The difference between VOD and live application is VOD delivers from existing file. Live delivers live stream that is being ingested from an encoder. If you put live on, then it enables live mode for that application. Then you can publish a stream to that application, and you can play the stream from that application. NGINX Rtmp module also supports HLS live. You can enable HLS on a live application by adding HLS on, and you specify HLS path. That is where the HLS files are generated by NGINX. And you specify HLS fragment, that is the target duration for each HLS segment. You can also enable dash on a live application by adding dash on and dash path. That is where the dash files are generated. And you specify the segment duration for dash. Let me show you how it works. So I'm running NGINX with Rtmp module. I'm publishing a stream using FFmpeg. Then you can see that the files are being generated by NGINX Rtmp module. The first segment was complete. The second segment is being appended. Now it generated the third segment. HLS files are generated there, and dash files are generated in dash directory. Now we have seen that NGINX Rtmp module can do Rtmp VOD and live and HTTP VOD. No, sorry, HTTP live. Then what we are going to do about HTTP VOD? HTTP VOD can be prepared using tools like FFmpeg. You can run FFmpeg using these parameters. Then FFmpeg generates HLS manifest file and HLS segment files. You specify the segment duration by dash segment time 10. That means segment duration has to be 10 seconds. And you specify the segment format, MPEG-TS. HLS segment has to be packaged in MPEG-TS format. Then those generated M3U8 manifest file and TS segment files can be delivered over HTTP. You can also generate dash files using a different tool called MP4 box. That is in GPAC package. If you run MP4 box using these parameters, then you get files for dash streaming, manifest file, and with .mpd, and you also get segment files. Then you just put those files into the web server, and then you can deliver them over HTTP. We don't like this method. The biggest reason is we don't like to add an additional step before we provision the video file. Every time we make a new file available for viewing, we have to run FFmpeg and we have to run MP4 box. That is annoying. And also, it consumes triple storage because we want to keep MP4 plus HLS plus dash. And if we want to change a parameter, like if you want to change the segment duration from 6 seconds to 4 seconds, then it means that you have to reprocess the entire content library. If you have only a couple of files, then it is not a big deal. But if you have hundreds of thousands of files, that it means that if you just want to make a single parameter change, then you have to rerun FFmpeg and MP4 box over hundreds of thousands of files. That is something you want to avoid. So the question here is there any way to generate HTTP streaming files like manifest and segment for HLS and manifest and segment for dash on the fly? On the fly means the files are generated only when they are requested without having to pre-process the entire file. NGINX Plus offers some streaming features. And the streaming features offered by NGINX Plus is exactly HTTP VOD that is not covered by NGINX Rtmp module. If you install NGINX Plus, you can define HLS application by adding HLS inside the application with HLS fragment. Once you do that, then when you make a request for M3U8 manifest file, then NGINX Plus is dynamically generating that manifest out of the original MP4 file. And when your client makes a request for segment file, then NGINX Plus is dynamically generating that segment file and returns it. NGINX Plus can also do HDS as well as HLS. But HDS support is not complete. You need to run FOF packager to generate FOF file in advance. FOF packager is from Adobe. So there is no great benefit by using HDS feature from NGINX Plus. We don't like this either because NGINX Plus is a little expensive. All you want is just streaming. Then maybe you don't want to pay that much money. And some people don't like the HLS from NGINX Plus. NGINX Plus doesn't make a unique file name for each segment, but it uses query string to identify different segments. So every segment has the same file name. First segment has query string like $start equals 0 and end equals 10. That represents the first 10-second segment. The second segment has start equals 10, end equals 20. In most cases, it is okay, but in some situation, having the same file name for very different file with only different query string may make some issue with some caching infrastructure. And another thing is HDS support by NGINX Plus is not complete. It still requires an additional pre-processing. And MPEG-DASH is totally missing. So what we have got so far is NGINX Rtmp module can do Rtmp live and VOD. NGINX Rtmp module can also do HLS and dash live. NGINX Plus can do HLS and HDS. And NGINX Plus can also do HDS, but it is not complete. The question here is there any way to get HLS and dash VOD on the fly without spending too much using the basic NGINX. I'm going to discuss some methods to achieve that. So the most important part of segmenting a file and repackaging is how to cut a file into smaller segments. We can do that using FFmpeg. FFmpeg can take -ss and start time, -t, end time. If you run this, then you get the first 10-second segment. If you put 10 as the start time, 20 as the end time, then you get the second 10-second segment. Then you can get the third 10-second segment. What makes it a little tricky is there are two different types of frames. First is iframe that has all information required to decode itself. The other kind of frame is P frame and B frame. For simplicity, I didn't include B frame here, but in the sense that they don't include the full information, but has only the difference between two frames. They are similar to each other. I frame can be located anywhere in a file. P frame cannot be the first frame. In this example, I frame has been inserted every 10 seconds regularly. It is an extremely rare case in the real world. In reality, most MP4 files that you are going to work on will look like this. If you segment in the same method, then you get the first segment, that is okay. You get the second segment, it doesn't play because the first frame is not iframe. You get the third segment, it doesn't play. The first frame is not iframe. Then how can we make each segment playable? We have to, the segment size has to be adjusted by the location of iframe. So the first iframe has to start from the first segment has to start from the first iframe and ends at the next iframe. Sometimes the next iframe comes a little later than usual. Sometimes the next iframe comes a little earlier than usual. The iframe location is unpredictable. And as a result, the segment duration is unpredictable. The main question here is, how are we going to get the key frame location in advance? Without that information, we are not able to generate any single segment. We can get that information by running FFprop. If you run FFprop with that parameters, then FFprop returns the location of each iframe. Then you have the list of iframes, and you know what the manifest has to look like. Then you can combine those two information to construct the manifest file for that particular MP4 file. You have certain rules, and you apply that rule, then you get this M3U8 file. And in this M3U8 file, you get the list of segments, and each segment has suffix, and the suffix represents the start time of that segment. When the player requests for the segment file, then we know where the start time is. Then we run FFmpeg, and we cut the segment, and we repackage the segment using FFmpeg with those parameters. Then we return that generated segment to the client. Let me show you how it works. So I added these rules. If we receive requests for M3U8, the server runs this FastCGI script to generate manifest. If we get, okay. So if we get request for TS, we run this FastCGI script to generate the TS file. I implemented that as a FastCGI script just for quick prototyping, and there must be a better way to do that rather than FastCGI script. Let's take a look at the FastCGI scripts for generating manifest. So we get the request, then we run ffprop to generate the list of iframe locations. Then we use that information to construct the manifest file. And when we receive a request for a segment file, then we get the suffix to identify the start time for that segment. And we run FFmpeg to create that segment. And we run FFmpeg again to repackage the segment using MPEG-TS file. Then we return the generated segment. So when we make the request, the server runs that FastCGI script and generates the manifest for that MP4 file. If we actually play that HLS stream, we play the HLS stream using an HLS player. We can see that we receive the request for M3U8 file, and we receive the first TS file, second TS file, and third TS file, and they are all generated by the FastCGI script and FFmpeg, and then they are returned. MPEG-DASH can be generated using a similar method. You get the locations of iframes, then you have a dash manifest template, and you can combine those information together to construct dash manifest file. You can also generate dash segment files. One difference is in case of dash, players don't normally like the segment files that have video and audio tracks in the same segment. So to make those players happy, we generate segments twice. First time with -an, that means no audio. Then we get video-only segment. Second, we put -vn, that means no video, and we get audio-only segment. Then we repackage those two segments using MP4 box. and we generate video segment and audio segment for MPEG-DASH, and we return those segments to the player. Then, now we know how to do Rtmp live and VOD and HTTP live and VOD. Then we can set up a streaming server using NGINX combined with FFmpeg, MP4 box, and Rtmp module, and some FastCGI scripts or some other methods to link the incoming request with FFmpeg and MP4 box. Then we are running a multi-purpose streaming server using NGINX. When we get a request for an MP4 file over HTTP, we can just serve the file over HTTP. That is the case when the client is capable of HTML5 or trying to play the video using progressive download. Some other clients that has Adobe Flash Player makes a request over Rtmp. Then NGINX Rtmp module can return the content over Rtmp protocol. If an Apple device makes a request for the content over HLS, it makes M3U8 request, then we can run FFmpeg to generate the manifest and segments and return M3U8 manifest and TS segments. When the client makes a request for dash contents, then we can run MP4 box to generate the dash file, and we return MPD manifest and M4A, M4V segment files to the clients. For this way, using this way, we can offer different streaming protocols that is probably cover most of the clients. That's it. Any questions? Yes.
Consider doing your own HTTP server instead of NGINX so that you have more control of how you want to deliver.
Oh, sorry.
Your own HTTP server
yes.
Instead of NGINX.
Instead of NGINX.
Have you considered that?
Yes. It can be actually any HTTP server, but NGINX has a very good third-party module called NGINX Rtmp module that already does Rtmp live, Rtmp VOD, and HTTP live very well. So the only thing that is missing is HTTP VOD. So using this method, HTTP VOD can be implemented on any HTTP server, not only NGINX. But the reason NGINX is great for streaming is it already has the open source module called NGINX Rtmp module. That is doing its job very nicely.
Another question, is it possible to write another module like Rtmp module where you handle the HTTP VOD?
Yes, definitely it will be also possible. But I haven't tried to do that. Okay.
You know, someone said Rtmp is dying, and almost every Indian company has Rtmp very much.
Right.
Which protocol do you think will be the replacement for Rtmp for real-time learning?
Yes. Yes, many people believe that Rtmp is dying. So we have seen that streaming traffic is moving out of Rtmp. And the destination is HTTP protocols like HLS and DASH. It used to be HDS, and it is losing its foothold now. So we expect that most streaming traffic is moving towards HLS and MPEG-DASH, but somebody still wants Rtmp. The biggest reason is there is no other protocol that can allow that short end-to-end latency. If you stream over HLS or MPEG-DASH, it is very hard to achieve low latency. So it is really hard to make the end-to-end latency less than 10 seconds. But in case of Rtmp streaming, it is not that difficult to do 2 to 3 seconds of delay. Some people really need very short latencies. For example, imagine that kind of situation. You want to run a streaming server, and your business is like you are streaming some gambling contents, and you allow the end user to bid based on their watching. And if there is 1 minute delay from the real event, then you'll be in trouble. For those kind of people, they really need Rtmp, and there is no other streaming protocol that can allow that short latency. So for those kind of application, we believe that there must be certain needs that will still need Rtmp more than we want.
So we do have any try
Try any?
Now we just can use Rtmp.
Yes.
And maybe for in the future, for a long time, we also use Rtmp for real-time learning.
Yes. We expect that basically everything should be moved to MPEG-DASH or MPEG-DASH plus HLS. People really don't like Rtmp, but certain kind of application still needs Rtmp. So there is no good alternative for that kind of situation that requires low latency. Thank you. Oh, yes.
You didn't touch on the depth bit rate at all. Can you speak to that bit rate for both the live and your
Oh, sorry. Can you repeat?
Adaptive bit rate.
Adaptive bitrate. Yes. Yes, I didn't include adaptive bitrate here. So once you can offer single bitrate, adaptive bitrate is not difficult. It just requires multiple files. Each one represents different bitrate. Then you can generate the stream level manifest for each one, and you can generate segment from each file. Then one thing that is missing is the set level manifest that includes the list of stream level manifest for each different bitrate. You can automate that using the existing MP4 file. That is not difficult to implement at all. So the most important part is more on the generation of the stream level manifest and segment rather than the set level manifest. And once it is done, bitrate switching is actually taken care of by the player, not the server. What the server has to do is to make sure that the set level manifest is generated correctly. Thank you.